Hi guys, so the homework that you have from class is from section 2.1b, and one of the problems on the homework, I think it's number 6 off the homework, is focused on the function x plus 4 over x. And it's asking you to find the equation of the tangent line. It gives you a point. I think it gives you 4 comma 5. So it's saying find the equation for the tangent line at 4, 5 on this graph. So I sketched the graph. You can use your calculator to sketch it. It's kind of an odd looking graph. Here's 4, 5 on the graph. Up at 4 and over here at 5. And what it's basically, the problem's basically asking is if you drew a tangent line, there's my tangent, what would the equation for that line be? So there's two things you're going after. You're going after the point and the slope. We've got the point. They gave us the point. So they did a lot of the work. We just have to figure out the slope. And we all know that slope comes from the derivative, so our work is to find the derivative. And we're using the longhand way, we're using the limit process. So I'm going to go through this problem a little bit. If I need f prime of x, I'm going to use that limit as h goes to 0, f of x plus h minus f of x all over h formula. And it's actually kind of a difficult one to do with this fraction involved because every time there's an x, we're going to be adding a plus h. So it's going to get a little messy at first. This is what it's going to end up looking like. We're going to have f prime of x equals, the limit as h goes to 0. We're going to plug in the plus h. So instead of x, we're going to have x plus h plus 4 over x plus h. And I'm going to put a bracket around all of this. That thing in the bracket, that's f of x plus h. Now we want a minus, and I'll make another bracket, f of x. Well, that is x plus 4 over x closed off. And then all over h. And this is the fun limit that we get to try and solve. So, I'm going to move this up. Let's go through the process of solving this thing. We can't plug in chug, we'd get 0 in the denominator. But it is solvable. The very first thing I see is I have minus x minus 4 over x. So I see that x minus x are going to cancel. It's the first thing I can do. So I'm going to rewrite this as equals the limit as h goes to 0. I'm going to clean this up to h plus 4 over x plus h minus 4 over x. And I know that the whole thing is all over h, so I could draw like a all over h here, but the stacking of the fractions is pretty bad. So I'm going to take this whole thing and instead say times 1 over h. It's kind of the exact same thing we used to do with like kingpin problems. Move that fraction up. And then I'm going to multiply 1 over h in with all three of these. So I'm going to distribute. So I'm going to have the limit as h goes to 0. See where this one gets kind of fun. We're going to have h times 1 over h times 1 over h, plus we're going to have 4 over x plus h times 1 over h, minus 4 over x times 1 over h. It's messy, but we multiplied 1 over h by all three things. The one thing I see right away is I get some cancellations. So that's going to cancel, and it's just going to be 1. So that's kind of nice. So I'm going to rewrite this as the limit as h goes to 0. I'm going to kind of try and clean this up. Let's see. 4 times 1 is 4 over h times x plus h. So h times x plus h. Minus 4 times 1 is 4 over xh. I probably want to try and get these fractions together. I think that would be another good step, try and combine all this. So I'm going to go down to the next step here and do the limit as h goes to 0. And then to make my life a little bit easier, I should have multiplied this in probably and called this hx plus h squared. So I'm going to do that because I think that'll be simpler. And then common denominator time. So I have 1 plus a big fraction. The common denominator here is not going to be an easy one. What I'm going to end up doing is multiplying these two denominators together. So I'm going to do I'll write it in blue here, xh times hx plus h squared. Multiply the denominators. Then I'm going to cross multiply on top, so I'm going to have 4 times xh, so 4xh minus 4 times hx plus h squared, and that's going to be my push together combined fraction. It's pretty hideous, but it will clean up. So we go to the next step. Equals the limit as h goes to 0. We still have 1 plus out in front that I'm ignoring. Now let's clean up this fraction as much as we possibly can. So we'll move it down some more. And I'm going to multiply this 4 in. So I'm going to have 4xh minus 4hx. Why don't we rename that xh? It's the same thing. Minus 4 times h squared all over. And then I'm going to multiply out the bottom. xh times hx, those are the same thing. So that's going to be x times x is x squared. H times h is h squared. Plus xh times h squared is going to be xh cubed. Ugh, it's still ugly. Okay, more cancellations are going to happen. 4xh minus a 4xh. Let's get rid of those. Then in the next step, I see that I have h's all over the place. I have an h squared, and an h cubed. So why don't we cancel out 2 h's from all of these and rewrite this. So we now have the limit as h goes to 0. We have 1 plus a big fraction, and the fraction's going to clean up a little bit here. Everything is canceling on top. We only have a minus 4 left over. So minus 4. All over on the bottom we have an x squared left plus a xh left over. And we're left with that. So yeah, it's not like we've made this problem tons better, but I can plug in 0 now. It's still got a fraction, but I totally can put 0 in where the h is. So I'm going to have 1 plus negative 4 over x squared plus x times 0. I'll use a parenthesis. X times 0 cancels, so I get 1 plus negative 4 over x squared. That's my derivative. We got it. So f prime of x equals 1 plus negative 4 over x squared. Here's my derivative, which is really good. Now, the thing about this derivative is it's not the final answer, even though we did a ton of work to get there. Look at all this work. Let's go back up to the top. Remember what we're really trying to do here? We're really actually trying to find slope, and it's slope at this point. So what we really want to find is the derivative at 4, 5. 4 is the x value, 5 is the y value. So we're going to plug this in. If we want the derivative at 4, x equals 4, then we go to our answer that we got, and we go and find f prime of 4. And we're going to do 1 plus negative 4 over 4 squared to get our answer. 4 squared is 16, but we can reduce all this down, and we're going to get 1 minus, there's a negative sign, 1/4. So 1 minus 1/4 is 3/4. There's our slope, 3/4. So now we go back up to the top, and we write that our slope is 3/4. And now we've got point and slope, and we can write an answer. The equation of this line is going to be y minus the y value, so y minus 5, equals the slope, 3/4, times x minus the x value, x minus 4. And this thing, you know, it's pretty messy, but right there, that's our answer. That's the equation for the tangent line. So it's got a slope of positive 3/4. That makes sense. It's going up. So I would want a positive slope answer. If my answer had turned out negative, I would have had a red flag right there. So final answer on that one. So hopefully that helps with number 6 on the homework. If you kind of were able to follow these steps, you can go back through the video and watch it a second time if you want. It should help you with like number 9 on the homework, which is another fraction problem. It's very, very similar. So there's a lot of work and a lot of steps. Just be really careful with all your denominators and kind of cleaning things up the right way. And don't forget when you get to the very end that the derivative is not the final answer. You still got to go find the slope and plug it in. So yeah, I hope that helps, and I'll see you guys in class.